Hello class, this is a video lecture of chapter 11 titled Simple Interest and Simple Discount from the Business Mathematics text. Learning outcomes. Find simple interest by using the simple interest formula. Find the maturity of a loan. Convert months to a fractional or a decimal part of a year. Find the principal rate or time using the simple interest formula. Finding the simple interest using the simple interest formula. The interest formula shows how interest, rate, and time are related. It gives us a way of finding one of these values if the other three values are known. So here we have the formula, the interest, principal, rate, and time. And that's what IPRT stands for. Okay? Interest equals the principal times the rate times the time, period. Identify the principal rate and time. The price paid for using money is called interest. Principal is the amount borrowed or invested. The rate is the percent of the principal paid as interest per period. Usually it's a period of 1 year. Time must be expressed in the same unit of time as the rate. So in other words, 1 year. Interest is an amount paid or earned for the use of money. Simple interest is interest earned when a loan or investment is repaid in a lump sum. The principal is the amount of money borrowed or invested, and the rate is the percent of the principal paid as interest per time period. Time is the number of days, months, or years that the money is borrowed or invested. So finding the interest paid on a loan. So here we have the principal, which is P, equals $1,200. The interest rate is 8%, or if you put it in decimal format, it's 0.08. The time is 1 year. So now here we have the interest formula again. The principal times the rate times time. So we plug it in. We have $1,200 times 8% as a decimal times 1 because the time period is 1 year. And we can calculate the interest at $96. The interest on the loan is $96. Find the interest on a 2-year loan of $4,000 at a 6% rate. So we have to pull out the most important parts of this example. It's a 2-year loan, so that's the time period. $4,000 is the principal, and 6% is the rate. And don't forget to make the 6% into a decimal point. And when you work that out, you get $480. Find the interest earned on a 3-year investment of $5,000 at 45% interest. Again, we have the time period, the principal, and we have the rate. When you work that out, $675. Find the maturity value of a loan. Maturity value is the total amount of money due by the end of a loan period, the amount of the loan and the interest. If principal and interest are known, add them. So here we have MV, which is maturity value, equals principal plus PRT. Remember, the P times R times T. So the maturity value equals the principal, and then in parentheses we put 1 plus the rate times the time. And here's an example of this to apply it to a real life situation. Marcus Logan can purchase furniture on a 2-year simple interest loan at 9% interest per year. What is the maturity value for a $2,500 loan? So here we have the maturity value, which is what we're trying to figure out, equals the principal times 1 plus the rate times the time period. So here we plug it in. Maturity value equals the principal, which is $2,500 from here, and then 1 is given. plus 9%, which comes from here, times 2, which is the time period of the loan. And when you work out the multiplication within the parentheses, you get 1 plus 0.18 times 2,500. Then when you add these two together, you get 1.18 times 2,500. So you get maturity value of 2,950. Marcus will pay 2,950 at the end of 2 years. So this is the principal plus the interest on the loan. Another example, Terry Williams is going to borrow $4,000 at a 7.5 interest. What is the maturity value of the loan after 3 years? So you already have the 3 most important parts to the problem to solve it. And when you work it out, it is $4,900. Another example, Jim Sherman will invest $3,000 at 8% for 5 years. What is the maturity value of the investment? And you can feel free to pause now if you'd like to work it out. Maturity value is $4,200. Convert months to a fraction or decimal part of a year. Write the number of months as the numerator of a fraction. Write 12 as the denominator of the fraction, because there are 12 months in a year. Reduce the fraction to lowest terms if using the fractional equivalent. Divide the numerator by the denominator to get the decimal equivalent of the fraction. Convert months to a fraction, Convert 9 months and 15 months, respectively, to years, expressing both as fractions and decimals. So here we have 9 over 12 months equals 3/4 or 3/4, which equals 0.75. So 9 months out of 12 is 75% of a year. 9 months equals 3/4 or 75% of a year, or 0.75 of a year. So now here we do 15 months over 12 months in a year equals 1. The remainder is 3. And then you move the denominator over, if you remember from previous week's lectures. And that can be reduced to 1 and 1 over 4, which also equals 0.75. 15 months equals 1 and 1 over 4, or 1.25 of a year. Here's an example. To save money, Stan Wright invested $2,500 for 42 months at a 4.5% simple interest. How much interest did he earn? So here we bring over the 42 months. 42 months over 12 months in a year equals 3.5. So 3.5 months. And now here we have our interest formula. Interest equals principal times the rate times the time period. We plug that in from the information that's given in the problem. 2,500 is the principal. 0.045 is the interest, because if you take this decimal and you move it over 2 times to the right, we get 4.5. So this is the same thing as saying 4.5, 4.5%. So don't make the mistake of putting 0.45, because that's not 4.5, that's 45%. So then 0.045 times 3.5, the interest is $393.75. Stan will earn this much, $393.75. Here's another example. Akiko is saving a little extra money to pay for her car insurance next year. If she invests $1,000 for 18 months at 4%, how much interest can she earn? $60. Habib is going to borrow $2,000 for 42 months at 7%. What will be the amount of interest owed? And if you'd like to put the video on pause, feel free to do so. The answer is $490. Find the principal rate or time using the simple interest formula. So here we have, this is a good chart to keep or to print out so you can know the formula for each one. Here we have the formula for interest, we have the formula for principal, the formula for the rate, and the formula for time, if you have to look for any one of these things. So the interest formula is principal times rate times the time. To get principal, you do the interest over the rate times the time. And you want to make sure that when you're doing this, you put like an imaginary parentheses here because you want to solve for this first. The formula for the rate is the interest over the principal and the time. So you can put, again, an imaginary parentheses around that. And the time formula is the interest over the principal times the rate. Find the principal using the simple interest formula. Judy paid $108 in interest on a loan that she had for 6 months. The interest rate was 12%. How much was the principal? So remember here, now we're looking for principal, so we'd be referring to this one right here. Okay, so we need interest, rate, and time. Do we have that? Yes, we have interest, we have rate, and we have time. So we have enough information to solve this problem. Substitute the known values and solve. So again, here we have the formula for principal.
It's 10:30.
Principal equals interest over the rate times the time. So then we have $108 over 0.12, which is the decimal version of the percent up here. And the time period is 6 months, and 6 months is half of a year, and half of a year is presented as 0.5. So you have to remember, whenever you're presented information in months, you have to convert that to, you have to put that over 12 because there's 12 months in a year. So when you work that out, you get, you find out that the principal is $1,800. Find the rate using the simple interest formula. Sam wants to borrow $1,500 for 15 months and will have to pay $225 in interest. What is the rate he's being charged? Substitute the known values and solve. So here we have again the rate formula, and rate is determined by putting the interest over principal and time. So I over PT. So here we have I over PT equals R. R equals 225, which we have from the problem, over 1,500 times 1.25. And remember, it's 1.25 because we're putting 15 months first over 12 and then determining the 1.25. So when you work it out, you work out the bottom first, since you have to clear out the parentheses first, and then do 225 over that. And when you work it out, the answer is 0.12 or 12%. So that's the rate. The rate Sam will pay is 12%. Shelby borrowed $10,000 at an 8% rate and paid $1,600 in interest. What is the length of the loan? Substitute the known values and solve. So we have the time formula, which is T equals I over PR. T equals I over PR. We bring down the known. We know that the interest paid is $1,600 over the P times R, which is $10,000 times 0.08. And when you work that out, you determine that the length of the loan is 2 years. Learning outcomes. Find the exact time, find the due date, find the ordinary interest and the exact interest, make a partial payment before the maturity date. Key terms: ordinary time. Time that is based on counting 30 days in each month. Exact time is the time that is based on counting the exact number of days in a time period. Find the exact time. The ordinary time from July 12th to September 12th is 60 days. Find the exact time from July 12th to September 12th, add the following to find the period between those 2 days. So days in July, there's 31 minus 12 equals 39. And days in August, there's 31. And days in September, there's 12. 62 days. So there's a way to find out how many months, how many days there are in a month. So if you hold out a fist and you count, if you count your knuckles, you have 1, 2, 3, 4 knuckles, and then in between each knuckle you have like a little space, right? So if you start from the left, holding your left fist out, and then you touch the knuckle that corresponds to the pinky, if you go, if you touch it, it's January, has 31 months, right? 31 days rather. And then if you the next is the gap, which is February. It does not have 31 days. March does, April doesn't, May does, June doesn't, July does. So that if you use that knuckle format, July, August also has 31 days. So it's always going to be like that. February is the one that has the 28 or 29 days based on the year, but the 31 days is always going to be the same every other month. With the exception of getting to July and August. In that case, you go back to the first knuckle. So you can Google it and find out the method, but it's something that I use to try to determine how many days are in a month using the knuckle format. Sequential numbers for dates of the year. Find the exact time of a loan using the sequential numbers table, which is table 11-1 in the text. If the beginning and due dates of the loan fall within the same year, subtract the beginning date sequential number from the due date sequential number. So from page 394, the example is from May 15th to October 15th. You have 288 minus 135, which is 153 days, exact time. Find the exact time from May 15th of year 1 to March 15th in year 2. So you have 365 minus 135, which equals 230. 230 plus 74 equals 304 days. The exact time is 304 days. Note, if year 2 is a leap year, the exact time is 305 days. There's also websites too that calculate the number of days between days, so you can also feel free to use that. I mean, you're not really expected to count the number of days in a year, or the number of days between two dates. It's not logical. So find the due date. Subtract the beginning date sequential number from 365. Add the due date sequential number to the result from the previous step. If February 29 falls between the two dates, add 1. Is it a leap year? A loan made on September 5th is due July 5th of the following year. Find A, ordinary time, B, exact time in a non-leap year, and then C, the exact time in a leap year. So ordinary time is 300 days, exact time, non-leap year, is 303 days, and the exact time of the leap year is 304 days. Find the ordinary and exact interest. An interest rate is normally given as rate per year. If the time period of the loan is in days, using the simple interest formula requires that the rate also be expressed as a rate per day. Ordinary interest assumes that there's 360 days per year, so you have to remember that, not 365, 360 days per year. Ordinary interest is a rate per day that assumes 360 days per year. Exact interest is rate per day that assumes 365 days per year. Okay. And the way that I remember this is O, ordinary, it ends in O, 360, ordinary, 360. And then exact interest, there's 1, 2, 3, 4, 5 letters in exact, and it ends in 5. Okay, so O ends in O, exact does not. Banker's rule is calculating interest on a loan based on ordinary interest, which yields a slightly higher amount of interest. For the ordinary interest rate per day, divide the annual interest rate by 360. ordinary interest rate per day equals interest rate per year over 360. For exact interest rate per day, divide the annual interest rate by 365. So exact interest per day is interest per year over 365. Use ordinary time to find the ordinary interest of a loan. A loan of $500 at a 7% annual interest rate, or APR. I know there's no P in here, but it's annual percentage rate. The loan was made on March 15th and due on May 15th. The principal is $500. So here we have the formula once again. I, which is interest, equals principal times rate times time. The length of the loan in ordinary time, remember, is 60 days. The rate equals 7% over 360 days, which is ordinary interest, member O, member. Interest equals 500 times 7% times 60 over 360, which equals $5.83. A loan of 500, let me see. Is this the same exact thing? Okay. A loan of 500 at 7% annual interest rate. The loan was made on March 15th and due May 15th. Principal 500. Length of the loan, exact time, 61 days. So now we're not doing ordinary time, we're doing exact time. The rate is 7% over 360. Is this the same thing? No. Okay. So here we have 500 times the 7%. And then in parentheses, we got 61, which is the exact time, over 360, which is $5.93. The rate equals 7% over 365, ordinary interest, 500 times 7%. You know what, for this, I would recommend that you revert back to the section 11-2 in the book, because I think some of there was a mistake in across these slides. Make a partial payment before the maturity date. To find the adjusted principal and adjusted balance due at maturity for a partial payment made before the maturity date. The first step is to determine the exact time from the date of the loan to the first partial payment. Step 2, calculate the interest rate using the time found in step 1. Third step, subtract the amount of interest found in step 2 from the partial payment. Step 4, subtract the remainder of the partial payment from step 3 from the original principal. This is the adjusted principal. Fifth step, repeat the process for additional partial payments. Step 6, at maturity, calculate interest from the last partial payment and add to adjusted principal. This is the adjusted balance due at maturity. So here's an example. Tony borrows $5,000 on a 10% rate, 90-day note. On the 30th day, Tony pays $1,500 on the note, or I should say $1,500. If ordinary interest is applied, what is Tony's adjusted principal after the partial payment and adjusted balance due at maturity? So here we go. We have $5,000, which is the principal times 10% in decimal format. And here in parentheses, we have 30 days divided by 360, which equals $41.67. When you work out this part of the equation, you have 1,500 minus. Okay, you have 1,500 minus 41.67, which equals 1,458.33. 5,000 minus $1,458.33 equals $3,541.67, which is the adjusted principal. Then we have $3,541.67 times 10% times 60 divided by $360 equals $59.33, which is the interest. And now we have $3,541.67 plus $59.03 equals $3,600.70, which is the adjusted balance. Learning outcomes. Find the bank discount and proceeds for a simple discount note. Find the true effective interest rate of a simple discount note. Find a third-party discount and proceeds for a third-party discount note. For the bank discount, use the bank discount equals face value times discount rate times time. which again is I equals P times R times T. So that seems to be the key formula here. For proceeds, use proceeds equals face value minus bank discount, which is A equals P minus I. So here we have a promissory note which has the face value 4,000 and then 4,000. It's like very similar to a check. Maturity date September 5th, 2005. The interest rate here 8%. The maker, we have the term 90 days and the date. To find the true or effective interest rate of a simple discount note, the first step is to find the bank discount or the interest, I equals PRT. The second step is to find the proceeds. Proceeds equals principal minus bank discount. The third step is to find the effective interest rate, which is R equals I over PT, using the proceeds as principal. And don't forget that you have to put a parentheses over the PT. Here's an example. What is the effective interest rate of a $5,000 simple discount note at an ordinary bank discount rate of 12% for 90 days? So the first step is I equals PRT. So then we can plug in what we have. I equals 5,000 times 12% times 90 divided by 360. I equals $150. That's the bank discount. Proceeds equal 5,000 minus $150 equals 4,850. So here we have the formula R equals I over PT. So R equals, to determine the rate, $150 over 4,850 times 0.25. Do the bottom first. So then the rate is 0.12371133402, or just 12.4. R, or the effective interest rate, is 12.4. For the bank discount used, third-party discount equals maturity value of the original note times discount rate times discount period. For proceeds, use maturity value of original note minus third-party discount. A equals P minus I. So here's an example. Mihawk Trailer made a note for $10,000 with Darcy Mihawk, owner, at 9% simple interest based on exact interest and exact time. The note is made on August 12th and due November 10th. Since Mihawk Trailer needs cash, the note is sold to a third party on September 5th. The third party agrees to accept the note with a 13% annual discount using the banker's rule. Find the proceeds of the note. To find the proceeds of the note, we find the maturity value of the original note and then the third party discount. So the exact time is 90 days. We have 314 minus 224. I equals PRT. Plug in what we know. I equals $10,000 times 9% times 90 divided by 365, which equals 221.92 cents. Maturity value equals P plus I. That's $10,000 plus $221.92. Maturity value is $10. That should be a comma. Sorry about that. I didn't make these PowerPoints. The book did. The publishers, anyways. $10,221.92. Find the proceeds of the note. Exact time of the discount period is 66 days. Between September 5th and November 10th. Ordinary discount rate is 13% divided by 360. Third party discount is I equals PRT. Third party discount, $10,221.92 times 0.13 divided by 360 times 66. Third party discount is $243.62. Proceeds, A equals P minus I. So we plug in what we have, $10,221.92 minus $243.62 equals $9,978.30. And this concludes chapter 11 of our business mathematics text. For those of you who actually have been watching these video lectures, I really appreciate it. It makes it feel worthwhile to produce these videos. And I think what I'm going to start doing from now that we're at the midpoint of this course moving forward is giving extra credit to those students who have been watching these videos. So for extra credit, all I need you to do is just send me an email with the animal that's on my desktop. And that will demonstrate to me that you have been watching these videos, and it makes it, like I said, makes it worthwhile. So if you can tell me what this animal is, just write it to me in an email. I'll give you additional credit for engaging in this part of the class. Thanks for watching and have a great day. As always, if you have any questions, comments, or concerns, feel free to email me at any time.